Okay, here's 5.1. If you want any of your grades to be on first quarter, they've got to be turned in by Friday. Any late assignments, anything's got to be turned in before Friday. I may or may not accept work after the fall break, okay? It's up to me. I think that whatever happens in first quarter should stay in first quarter. But that's, we'll talk. But if you want it on first quarter's grades, it's got to be in by Friday. All right, Pythagorean theorem. That's not really what we're talking about till the very end, but right now we're talking about square roots. Most of this lesson is going to be about square roots. Like right here, we've got the square root of 27. We can make this what's called simplify. We can make it easier. So in all the work to the left, we're going to split this into 3 times 3. Sorry, 3 times 9. Split the 9 to be 3 times 3. I find my pair, pull it out, and I get 3 times whatever's left out. Left over is a 3, so we say 3 times root 3. And there's my final answer. I've taken root 27 and made it easier by saying it's 3 times root 3. Over here, we're going to look at this problem. So we were given this information. We're given 2 times root 63. 63 can split to be 3 times 21, which can split to be 3 times 7. Either way, we get 3 times 3 times 7. We pull out our pairs, and we end up with taking out the pair to get 6 times root 7. So when we do this, we're simplifying the square roots. So on this question here, we have to rationalize the denominator. This is a review from algebra. I've got to take care of this. There can be no square roots on the bottom. When I look at this problem, I times it by root 40 over root 40. I will always do that. Whatever square root's on bottom, I times it by the whole thing, okay? So if I have root 100 down here, I'm going to times it by root 100 down here. Now, lots of times people try and simplify the fraction beforehand. That's up to them. I like to do it this way no matter what. I'll show you other ways to do it later on in the lesson. But either way, root 40 times root 40 becomes just 40. It's like undoing itself. This is like root 40 squared. They just undo themselves and we're left with 40. All right, on top I have 4 times root 40. Now I can simplify that fraction. 4 over 40 just becomes 1 over 10. I don't write the 1 because it doesn't change anything. So now I have root 40 over 10. But I'm not done. I can do more with this 40. I can simplify that 40 a little better. Now we're going to talk about how to simplify the radical. This we've done before. We split it again, we pull out our pair, and we multiply the 2 and the 5. That's just simplifying the top. That's just making this top simplified. So I look at that and I put it on top. But now that it's over a 10, a 2 over 10 can be reduced to be over a 5. So now my final answer is root 10 over 5. When I simplify this radical, I multiply by the bottom to the top. So times root 40 times root 40. I simplify my fraction, I simplify my radical, and then I simplify my fraction again. So right here, I like to think about this as raising the drawbridge. Okay? When I have a square root times a square root, we can combine them into one big square root of 12 times 50. Okay? When I do that, I get to have, oh geez, what did I do? All right, so square root of 12 times 50. I split this into 3 times 4, 2 times 2, 5 times 10, and 5 times 2. I find my pairs. Here's my pair. Here's my pair. I get 2 times 5 times the square root of whatever's left over. 3 and 2 is left over. 3 and 2. And then I end up with 10 times root 6. That's a 3 times 2. All right, so there's my final answer, 10 root 6. All of this simplifies to become just 10 root 6. Right here, we look at the problem, we say we've got 9 root 2 over root 75. I've told you we cannot have a square root on bottom, so we need to rationalize it. Now, this is kind of a big number. I'm going to simplify this first. So I can take the 75 and make it 5 times 5 times 3. Well, I can pull that 5 out in the front now, and I end up with 5 root 3 over 9, under 9 root 2. So now remember how I told you I times the top and the bottom by whatever the radical is on bottom. So now I'm going to times the top and the bottom by root 3. This goes away and just is left with a 3. So I say 5 times 3 is 15. 9 times root 3 is, I got a root 2 and a root 3. I combine those together to get me a root 6. The 9 and the 15 reduces to be a 3 and a 5. I've got a 3 here, a 5 here, and a root 6. Remember how we raised the drawbridge and we get 2 times 3 is 6, and it stays under the radical? My final answer is 3 root 6 over 5. So figure out what a square root actually means. What to you does a square root mean? It could mean something times something equals something else. It could mean a radical. It could mean a way of finding an answer. I mean, just kind of give me what you think the square root really means. To me, the square root of a number is finding out what times itself is that number. So the square root of 25 would be 5 times 5. So the square root of 25 is 5 because 5 times 5 is 25. So on the test, on chapter 5, 6 out of the 9 problems have square roots. And then right here, 5 out of 8 problems have square roots. All 10 questions in part 3 have square roots. And then 4 out of the 10 problems have it here. That means out of the test, 25 out of 37 problems have some kind of square root. That's 67% of your test is based on your knowledge of square roots. Moral of the story, you've got to become the master of square roots. You've got to master that skill. Okay? Practice, practice, practice. Now right here we're talking about the Pythagorean theorem. So in a right triangle, it only works with right triangles. The square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. That means that C is always the hypotenuse. It's always the one that's across from the 90-degree angle. So C is always here, always the longest side. A is here, B is here. They don't really matter which order they go in. All we care about is that we know that they're not the hypotenuse. So C squared equals A squared plus B squared. And I want to show you a diagram or a demonstration of this. Here we have a black triangle right here in the middle. It's kind of a dark gray. Okay. And currently, let's talk about this side length here. If I move this side length here to be a 3, the area of the square built next to it is 9, right? Because 3 times 3 is 9. Now I move this triangle here to be a 4, and that means that the area of the green square is now 16, because 4 times 4 is 16. Now what's interesting about that is the area of the red square is given to us right here, 25. Well, when you think about it, what times what is 25? 5, okay. Then that means the length of this side right here is 5. So I have a 3 side, a 4 side, and a 5 side. And I did all of that just using squares built off of this triangle. So if I increase the side of this length here, 16, this area of the polygon became 32. So 4 squared plus 4 squared, that's 16 plus 16, does in fact equal the length of the hypotenuse squared of 32. So it doesn't matter what size the triangle is, 36 plus 16 equals 52. A squared plus B squared equals the hypotenuse squared. I could make it really big. Let's make it over here at 12. Right there. 36 plus 144 equals 180. If I bring this down a little bit, 25 plus 144 is 169. No matter how you do it, A squared plus B squared equals C squared. Now what's interesting about this is, look here, this is the length of this segment right here. A is, let's see, 13. The length of the green square, this side length, is 12. So yeah, the length of the red side is 13, the length of the green side is 12, and the length of the blue side is 5. So we talked about Pythagorean triples a while back. I asked you to memorize these special numbers, 3, 4, 5. That means the length of the sides, 3, 4, and 5, are all pretty numbers. 9 plus 16 equals 25, because 3 squared plus 4 squared equals 5 squared. Now, the other Pythagorean triple we talked about was 5, 12. Notice how when I land on 12, this length becomes a perfect little 13. Pythagorean triples are nice because they're not going to give you weird decimal places, like 5, 11, and ugly, right? It's not a pretty number. So it's easier to memorize the Pythagorean triples, like 5, 12, 13, than it is to have to do the square roots every single time. But regardless, this is kind of a little example of what the Pythagorean theorem is actually meaning. D squared, or whatever, blue side squared plus green side squared equals red side squared. Back to notes. So we look at this problem here, and I say here that we've got Pythagorean triples. Remember I told you memorize these ones? Memorize them. They're going to be on the test. You're going to see a triangle 7, 24, blank. And if you don't know your Pythagorean triple, you're not going to know 7, 24, oh, the hypotenuse is 25. Okay, or you're going to see 8, 17, and you're not going to know, oh, the other side's 15. So you're going to have to spend all this time doing square roots and craziness. It's not going to be fun. So right here, let's talk about using the formula. You want to determine what formula you need. Find the variables. Plug and chug. Plug means substitute. Chug means solve for the missing variable. And then you repeat the steps for any other ones you need to do. Okay, we got to use the results to solve the question. Okay. So now if we look at the cheat sheet right here, this is kind of cool. A, B, and C are three sides of a triangle if A plus B is greater than C, where C is the longest side. And I say that because if I have a triangle, it kind of makes sense that this piece plus this piece has got to be longer than this piece. If it wasn't, I'd have this little stick here, the long piece here, and then this piece here. They could never form a triangle because the longest we could get them to go would be right. I mean, this one's the longest it could be is about that long. Longest it could be was about that long. And they never touch. They never actually make a triangle. So the short sides have to be bigger than the long side. Now, when I say that, what's interesting is if I say a squared plus b squared equals c squared, then it's a right triangle. If this is true, it's a right triangle. If it's greater than c squared, then it's an acute angle. And if it's less than c squared, then it's an obtuse angle. Kind of some cool information about equals to, greater than, or less than. You may see that on the test. I'm not entirely sure if I'm going to put it on there or not. On your cheat sheet. Here, let's look at this question here. I've got 1, 2, and x. So I look here, I find my values, I plug them in my equation. Notice how x is c, it's across from the 90. So I say c squared equals a squared plus b squared, or x squared equals 1 squared plus 2 squared. That's substituting in. And then I go ahead and I put the exponents up, I combine like terms, I square root both sides, and I get my answer. Pause if you need to. Right here, I look at the next problem. I've got x, 8, and 10. I see that 10 is across from the 90. That's my c value. So I say these are my a's and b's. I plug them into the equation. So I get 10 squared equals x squared plus 8 squared. Handle the exponents, subtract over. I square root both sides, and I get 6. Oh, pause if you need to. Right here, next problem. Here's my triangle. I identify my c as 8. Here's my x, here's my y. I go ahead and plug them in. I handle the exponents. I subtract 16 over. I square root both sides. Square root of 48 is not good enough for me. I'm going to simplify that into factors. I'm going to pull out my perfect squares, which is 4, my pair. I pull out my pair, and I get 4 root 3. Pause if you need to. I got to go on. What does the Pythagorean theorem allow you to calculate? Take a moment. When I use the Pythagorean theorem up here, what was I solving for? It looks like in the picture I was solving for a side length. I was solving for x. So the Pythagorean theorem allows me to solve for the length of the side. All right, so right here, again, I find my variables. I plug them in. I go ahead and I take a look. I say, okay, root 2 squared is 2. 2 root 2 squared is just 2 times 2, 4, and root 2 times root 2, which is 2. I add them together to get 10. I square root both sides, and I get x equals the square root of 10. So right here, I look at this, and I say, we're going to have 3 problems like this on the test. Okay, be very comfortable with this type of a question. So on your cheat sheet, we're going to have the area of a triangle formula. We're going to use the Pythagorean theorem to find missing pieces of triangles and then use those missing pieces to find the area of a triangle. Okay, so remember we got to find the base and the height. The height is the perpendicular distance. So for a right triangle, it always works. The 2 legs are your base and your height. That doesn't always work. Always remember that we need to use the base and the height being the perpendicular distance. Notice these are 90-degree angles. That's because x is the base and 4